Hey y'all, welcome to 11.2. Today we are going to continue using sinusoidal functions, that's sine and cosine graphs, as mathematical models, meaning we are going to take a real world situation and we are going to apply that trig graph to it. So if we look at example 1, we have some information about the population of coyotes and county in Colorado. So remember, what we want to find in our graphs is a critical point, a high, a middle, or a low that's convenient to use as our starting point. That may not be when the situation started, but it's a spot where we can start the graph so we can write its equation. So as we go through this problem, we started tracking the population at time t equals 0 years. Now, we don't actually have the population at time 0, but we do know that a minimum number, that's a critical point, 200 coyotes occurred when t was 2.9 years. So there's a really good critical point to start our cycle. So it is a minimum, so it's going to start low. The number of coyotes was 200, that's on the y-axis. The time at which that happened was 2.9 years. So 2.9 years after we started timing, counting, collecting data, that population reached its minimum. So this tells us a few things about our equation. For starters, it's starting low, which means it has to be a cosine, and yes, it has to be reflected. Okay, we don't know anything else about the vertical yet, but we do know our horizontal shift is 2.9 units to the right. And all of that is from just that first data point. So from here, if we're using our sine graph, starting at the bottom using a cosine, if we sketch this, cycling through, then we can connect. Remember to connect those with curvies. That went awry. That's better. And so on. This won't actually end. It will keep going. And it didn't just magically start at year 2.9. It did exist before that. We just don't have those specific data. So the next thing we know is that we have a maximum, the next maximum. After this minimum of 200, the next maximum is 800 coyotes, and that occurred at t equaling 5.9 years. So our maximum, 800, tells us the top. And then that occurred at time 5.9. So this critical point is at 5.9. Now, this is enough to write the equation for this graph. And here's how. We know that from the low to the high was a gap of 3 years. So from that high to the next low is going to be another gap of 3 years. So that next low will occur 3 years later, 8.9. The next high will be another 3 years later, 11.9. And then that final, our next low will be, again, 3 years later, 14.9. Now, what that lets us backtrack to is the period of the graph. Remember, the period of the graph is that 8.9 minus 2.9, so that period is 6. It's one cycle. Now, we also need to find the midline, which will let us find the amplitude. We have the high and the low. To find the middle of two numbers, add them up and divide by 2. It's their average. The midpoint is the average of of two numbers. So that middle is going to be 500. That gives us our midline, which is our vertical shift. That also lets us determine the amplitude from 500 to 800 peak. That amplitude is 300. Now, we still need our B value. B we're doing these in radians, it may not say, but we are, is 2 pi over the period. So 2 pi over 6 or pi over 3. And here are 2 cycles of this data. Now, we need to write the equation. So y equals, we start with that vertical shift, which was 500, and that did go up. Then we have a plus, because we have a minus. We have a minus because we are not reflected. Then we have our amplitude, 300. And our trig function is cosine of the b value, which is pi over 3. Open a new one. X, that shifted to the right 2.9 units. So that is a minus 2.9. Again, those insides feel backwards. And this is our equation. So let's put this equation in y equals so we can graph it. Oh, I had this up here a minute. I hope it's still there. Nope. Okay. Sorry, I'm going to take a few clicks on this. That one, and this one, and this one, and calculator. All right, make sure you are set to radians. Go to y equals, type in our function. Graph this. Now, if I just graph this on a standard window, I can't see anything. Can't see anything at all. So we're going to have to go to our window and fix a couple things. So if we look at the x's, our cycle starts at 2.9, but the data told us we actually started timing at t equals 0. So I do want to see x equaling 0 on my window. And to get those 2 complete cycles, it ends at 14.9. I want to go a little higher than that so I can fully see those 2 cycles. So I'm going to leave that negative 10. Actually, I'm going to make it a little smaller. I'm going to make that x minimum a negative 5. I don't really need to see a whole lot of negative x's. That x max, I need bigger than 14.9. I'm going to call it 20. Leave those scales alone. And now let's talk about the y. The y's go from 200 to 800. So I want to see a little lower than 200 and a little higher than 800 on the graph. So I am going to set this window, the minimum, I'm going to set to 100. That maximum, I'll set to 900. And that scale, that's what we're counting by. Those are big numbers. I want to count those by 100 instead of 1 like normal. And now when I graph this, we can actually see the cycles of the population. So let's go to the questions and let's look at part C. Predict the population when t equals 7 years. That t equals 7 is an x. So it gave us the x. It's asking us for the y. So we can do this one of 2 ways. We can go to the home screen and we can plug in 7 for x. Or we can go to the table in our calculator and find where x is 7. So if we go to the table, second graph, go down to where x is 7. Now, only 2 decimal places are showing here. We need to round everything to 3. If you'll arrow across to the 7, to the Y column, from the 7 to its Y column, you get all of the digits. You'll need to do this on your assignment. So that population, Y value, is 622.021 because it does round up. So 622.021 is that population 7 years after it was being recorded. Now, we can kind of see where that is. We can estimate at least where that is on our graph. Let's do that one. 7. We have almost 6 years here. So a little past that would be about 7 years. Go to 7 years. We're between the 500 and the 800. So that 622 makes some sense. Okay, and that's just a rough estimate on that. Now, let's look at D. And it tells us that coyotes are endangered when their population drops below 300. We're looking for the first 2 non-negative values of T. Were they first endangered? So we're looking for the time. So it gave us that Y. That Y population is 300. So we'll make Y2 equal 300. Now, we can see on our graph about where 300 is going to be. It's going to be a little above that 200. So we're looking at this line, and we're looking at where the population was first endangered. And it's going to be here in this area. Even though we can't see all of that on our graph we put on paper, it still exists starting at time equals 0, and we can see that on the graph. So we'll make Y2 equal 300. We'll graph it. There's our horizontal line. Okay, so we are looking, we are looking at the first positive times where our graph has that little curve below that horizontal line. So to do that, do this from here. To do that, second trace, 5 for intersect, and then I messed that up. Second trace, 5 for intersect, enter, and then move the cursor. The first time they become endangered is right here where that cursor is blinking now. So hit enter a third time, and that will give me the number of years. That X value, 2.097, is the first time when they become endangered. 2.097. So T equals 2.097 years was that first time. And then we want to go back and find the second one. So that would be the one just to the right. So second calc, second trace, 5 for intersect, enter, scroll to where you're blinking on that next intersection, and then hit enter a third time. Again, be sure you see the word intersection on your calculator screen. So 3.703 years is when they got above 300 again and were no longer endangered. So between these two times is when this coyote population was first endangered. It's not the only time they were endangered, but from t equals 0, that was the first time they were endangered.